The final set of notes for topic 8 has to do with global warming. And it's important to understand the distinction between the greenhouse effect and global warming, where greenhouse effect is a necessity for life on Earth. Global warming should have more negative connotations. That it's kind of like the impact of humans on the Earth. And some of the possible causes, and based on data collected, the average temperature of the Earth is going up and is warmer than it's been in some time, and the average temperature each year has gone up to some degree. There's of course always variations. Some of the possible causes of the increase in temperature is the composition of the greenhouse gases. And when we talk about greenhouse gases, those are the things in the atmosphere that affect how much of the ultraviolet and infrared radiation stays trapped in the Earth. And the biggest causes of that change in composition are, of course, burning fossil fuels, which we have a direct impact on, and deforestation, which again we have a huge impact on. So really there are two negative things that are affecting each other. We're cutting back the number of trees, the amount of green that's on the surface of the planet to take in the carbon and produce oxygen, and we're also burning fossil fuels, which is adding more carbon dioxide to the atmosphere. So we're adding more carbon dioxide and we're decreasing our ability to get rid of the carbon dioxide in the atmosphere. Aerosols are not as much of an impact. They've been banned. So things like CFCs, when you hear talk about chlorofluorocarbons, that's not really an issue anymore because they've been banned worldwide for a pretty long time, so it's not as much of an issue. So those things are more human related, but we also have just natural cycles. One of the big things is solar flare activity. When there are more solar flares, when the sun is more active, there's more radiation that's emitted, and when there's more radiation that's emitted, there's more that hits the surface of the Earth, which then of course increases the amount of infrared radiation on the surface of the Earth, and so we have an increase in temperature. The sun has, we've tracked about an 11-year cycle that the sun goes through, where the amount of solar radiation kind of waxes and wanes over the course of that 11 years. There are also cyclical changes in the Earth's orbit. It's not a perfect orbit. It doesn't maintain the exact same eccentricity. It doesn't actually follow the exact same orbit forever. There are some shifts, some changes in its precession and its eccentricity, but those are very, very long-term, very large-scale cycles, and so for those we're looking 100 to 400,000 years for those impacts, so a very long range, but they certainly do have an impact. And then there's definitely the impact of volcanic activity, which when we have more active volcanoes, that puts more ash into the atmosphere, which then of course affects both the amount of sunlight that gets into the atmosphere and then also the amount that can escape or the amount that's trapped. Right now there's as many as 60 active volcanoes. That number obviously fluctuates in a given year or over a given course or a given set of years. And then continental drift, it affects where the actual water is in the oceans, where those currents and winds are impacted and how they move. So those are things that can all impact the average temperature at the surface of the Earth. Now, when we're talking about global warming, we're really talking about what's called the enhanced greenhouse effect. When we relate it to our man-made or our man's impact on the atmosphere. The enhanced greenhouse effect is kind of like, well, there's going to be a greenhouse effect. That's good. It's beneficial. It's what keeps the Earth warm enough for life. But then we have the enhanced greenhouse effect, which is looking more at man's influence on the greenhouse effect. How has it changed, or how is it changing? How is it being affected because of what we do? If we increase the amount of greenhouse gases, which is essentially what's happening, burning fossil fuels, adding CO2, cutting back on green things, trees, grasses, things like that, so we can't get more oxygen in. We're cutting back on the ability of the planet to undergo the carbon cycle and get that carbon dioxide out of the atmosphere. Then the amount of radiation absorbed by the atmosphere increases. This reduces the amount of energy that actually leaves the Earth, and so the temperature rises until we again have some type of equilibrium release, or reached rather. And all of this, everything that's going on, there's always nature always tries to reach equilibrium, but then humans got to come in and make it more difficult. We disrupt that equilibrium. We're not always trying to reach equilibrium. We're making it more difficult for nature to reach that equilibrium. It's believed that, as we mentioned, that the burning of fossil fuels and deforestation are the major contributors to this enhanced greenhouse effect, and it is debatable. You can read a lot of different articles from a lot of different sources, and they're going to cite a lot of different data, some that supports the idea of the enhanced greenhouse effect, some that denies it, some that goes against it. There are a lot of studies out there that say that we're going to head towards some giant environmental catastrophe because of the enhanced greenhouse effect. There are some papers out there that say that everyone who believes that global warming is happening is crazy. So there are two real significant sides here to this argument, and they both have data to back them up. Now, a lot of what happens is scientists take data and they skew it to, or they put it into a light in which their side is supported. Scientists can take the same data and they can interpret it in different ways, and they can come up with different conclusions. We know that happens. It happens all the time. And so it's really important anytime you read anything or watch anything related to global warming and greenhouse effect that you do so with all of your senses and capabilities on high alert, so to speak. Pay attention to what kind of side the people are coming from. Is it obvious that they're skewed? Is it attempting to convince you one way or another, or is it really just trying to be an informative article? Which is rare, because most people have an opinion and they try and put forth that opinion about what's going on. There have been a lot of controversy because there were emails that were leaked between people that said that they were going to essentially fabricate data. And so there have been accusations of fabricated data in this whole argument. So there are a lot of things that go on in the science community even that aren't so great. But the overall belief, or the widely held belief, is that we are having some impact on the greenhouse effect, that humans and their burning of fossil fuel has had an impact on the atmosphere and the greenhouse effect. Some of the evidence that is cited and some of the evidence that is looked to for this, one of them is the ice cores. And essentially what they do is they go up to Antarctica, they take these giant drills, they dig down, as you say, about 3,600 meters. So they get these huge, long cylinders of ice. And within the ice cores, you can actually see the different layers from the different years as the surface layers up. And you can analyze those layers, and based on the isotopes of hydrogen, H1, H2, or H3, and how much is in each of the layers and the water that freezes to make those layers, you can actually determine the temperature, or the rough average temperature at the time. When you find the heavier isotopes, so like H3, that means that there were colder temperatures in that time frame or in that time period, and so it allows us to, and allows scientists to kind of track the temperature over hundreds and thousands of years. And so if we look at a couple of these graphs, this upper left one here is an image of an ice core, and the years, so you can see how there's light bands and dark bands, and again it's affected by what is in the water at that time. If there's more pollution, less pollution, different things like that affect the coloring. But this is from starting in 1855, so a little bit older. Then on our bottom left, we have the atmospheric carbon dioxide concentration, and again, here's one where you can kind of see a significant jump. So it's relatively consistent from about 1000 to about 1800. We hit the Industrial Revolution, and now you have this huge jump where we go from about 280 parts per million up to 340 parts per million. So that's a fairly significant jump in the amount of carbon dioxide in the atmosphere. But also notice that if we look at these two graphs over here on the right, and notice with these two graphs that we're starting at our current time period at the origin and working backwards. So to the far right is our oldest time, far left is our most recent time. Notice the cyclical nature of both the carbon dioxide and the temperature. So if we trace back to about 400,000 years ago, you can see that we had a lot of carbon dioxide in the atmosphere and it was a fairly high temperature. But again, cyclical, we're working towards equilibrium. You can see that the amount of carbon dioxide comes down, and then it cycles back up, and along with that we have our average temperature cycling down and back up. And notice that there's a pretty direct relationship between the amount of carbon dioxide in the atmosphere and the temperature. Now it just so happens that right now we are in one of these upswings. Okay, we have a significant amount of carbon dioxide, and we also have a higher temperature than we did 50,000 years ago. So that's kind of one of the arguments against this idea of global warming enhanced greenhouse effect, that it's part of the cycle of the Earth. That we've seen this happen over and over and over again throughout the history of the Earth, that we have more carbon dioxide, we have a higher average temperature, and that in another 40,000 years we're going to see that go down and we're going to have another ice age. And so that it's not so much what humans are doing, it's just part of the natural cycle of the planet. Right now the current levels of carbon dioxide are higher than what we've seen in the past, though, even in some of the far distant history, and that's primarily due to burning of fossil fuels. And so as we increase that, we're increasing the amount of carbon dioxide, and again, deforestation decreases how quickly that carbon dioxide can be taken out of the atmosphere. And then the other component of that is, as the planet warms, we start to get an increase in the amount of snow and ice at the poles that's melting, which decreases the snow cover, which then increases the albedo. And so, as we talked about before, as that albedo goes up, we're going to tend to see increases in the average temperature. And then the other aspect of this that's not as much talked about is the idea that when you have warmer temperatures, you don't have as much gases dissolved in liquids. So gases, and you see this in your soda. When you have a can of soda and you pour it into a glass, if it stays cold, and that's why one of the reasons we put ice in there, it stays bubbly longer. If you've ever left soda out in the warm sun, it goes flat very, very quickly, because as the temperature rises, the gas comes out of solution much more quickly. Warmer fluids can't hold as much gas in solution as colder ones, and so as the ocean's temperatures rise, the carbon dioxide that's generally dissolved in the oceans is going to decrease because it's warmer water. It can't hold as much carbon dioxide. And so again, there's another place where we have an increase in carbon dioxide in the atmosphere. And one of the more overlooked, I think, parts of or impacts of global warming is the impact on the oceans, because when you change the temperature even by a small amount of the oceans, you have a huge impact on the water chemistry and then therefore the life that's in the oceans and the life that can exist in the oceans. So that's one of those I think less addressed, less talked about impacts that we deal with. And along with this, we have something called COVE, which is the coefficient of volumetric expansion. And essentially, it's addressing thermal expansion. When you warm something up, it expands. And the same thing is true with water, particularly with water. So when we warm up the planet, we warm up the oceans, we're actually going to see the oceans expand. And that, again, that could cause some rise in the sea levels, but it's difficult to predict exactly how much, because you have different rates of temperature change at the poles and at the equator and everywhere in between. There's a very uneven heating of the water. There's the idea that in that 0 to 4 degree range, the water actually contracts. It gets more dense, so the volume decreases. There are different effects of melting land ice and water ice, particularly in terms of sea level. All of the icebergs in the world could melt and the sea level wouldn't rise, right? Because icebergs are already floating in the water, that water's already been displaced. The only part that actually impacts sea level is when land ice melts. Now, from here, despite the arguments for and against pro-con global warming, even if we're not impacting the overall environment, the overall atmosphere in any significant long-term way, I think it's undeniable that humans are having an impact on the environment. Even if it's not really causing global warming, whether it is or isn't, we're having some impact on the environment due to our enormous energy needs. And so there's going to be debate about the extent to that. Regardless, it's important to look at ways to decrease our impact. Whether it's because you believe we're heading towards some ultimate worldwide crisis, or just because you understand that it's good to be concerned about what we're doing to the earth. And so there are steps being done from the individual to the corporate level, and I think we see that a lot even within our own community here. That we have a lot of very active people in things like the environmental club, and both within the school and out in the environment, or out in the community rather, excuse me. We have active recycling. We have a lot of people that are making commitments to decrease their carbon footprint and decrease their impact on the environment. Some of the things that are being done at all levels. The efficiency of power plants has increased significantly over the last 20 or 30 years. As technology improves, so does efficiency of our energy consumption and transfer. We're getting more energy out of the fossil fuels that we're using than we ever have before. We're using more natural gas and oil, which, as we talked about before, are both much cleaner than coal. We're using combined heating and power systems, and what you have there is using the waste thermal energy to drive some other process. More renewable resources. We've talked about a lot of the different resources that we can use that are non-fossil fuel. Hybrid vehicles. So there are a lot of different ways, a lot of different things that can be done to decrease the impact on our environment. Even just recycling, even little things like turning off the water when you are brushing your teeth, or not taking 3-hour showers, taking 5, 10, 20 minute or 5 or 10 minute showers instead of that 20 or 30-minute shower. So little things like that can have an big impact. More farther afield and kind of a larger scale internationally, you have things like the Kyoto Protocol and a variety of other partnerships that are internation agreements to work towards more energy efficient systems, to cut back on things like aerosols and a lot of those that are potentially damaging to the environment.